Okay, so problem number 44. Still in section 5.8. Gives us this integral. The integral of the square root of x minus 2 over x plus 1. And they make a suggestion. Now this one's kind of unusual. It's a weird way to work a u substitution, but it works. U equals the square root of x minus 2 is what they suggest. So, okay, let's go with that. What this is going to do is it's going to help us reshape our integral. Now, if this is true, then u squared equals x minus 2. Okay, and then I can move the 2 to the other side and get u squared plus 2 equals x. And that's nice, that's handy. Now I'm also going to need a term that involves the differential, my dx term. So I'm going to apply the derivative differential operator to both sides of this. That is, I'll take d by dx of both sides. And let's see what happens here. Here I'll get 2u du. Derivative of constant is 0. Here I'll get my dx term. Okay. We've got a lot of stuff here. Let's put it all into our integrand. Now, I'll give you a little heads up and reassurance that on a problem like this, they're giving you that u substitution. It's not a trick that you're necessarily going to think of, and we're not going to get that much practice with it that I expect you to find that on your own. But with that trick, let's follow it and see where it leads. The numerator is just going to be u. What's going to happen in the denominator? Well, x gets replaced by u squared plus 2 plus 1. And then dx gets replaced by 2u du. Let's clean this up a little bit. So, the 2, that's just a constant. I'll take that straight out of the integral and out front. U times u is a u squared du, and a u squared plus 3 in the denominator. One thing you might notice is that the degree of the numerator and degree of the denominator are the same. Now, I'm not saying that people in Calc 2 do this, but I'm also going to show you what you can't do. I get this all the time, a over b plus c. People split that up into a over b plus a over c. You can't do that. If it was flipped upside down, with something like this, then you might be able to get away with dividing both terms in the numerator by the term in the denominator. But you can't split up the denominator like this. So what can we do? Well, you can do a long division. And you're going to want to do the long division if the degree of the numerator is greater than or equal to the degree of the denominator. This is going to be the world record's shortest long division, right? There's not much to do here. How many times does u squared go into u squared? Once. So it's u squared plus 3. When you distribute that negative sign, you'll end up with a minus 3 here. So we'll write this as 1 minus 3 over u squared plus 3. All of that is du. Can you see why such a problem like this was included in section 5.8? What's this going to lead to? What's it building to? I'm thinking about this part right here. one of the inverse trig functions. Thanks, Hans. Yeah, this is going to be your arctan right there, right? Just, it looks a little different, but it's going to be an arctan. 2, what's the integral of that first one? U minus 3 times 1 over the square root of 3 tangent inverse of u over the square root of 3 plus a constant. Now, I could put the plus a constant in here. I'm going to leave it outside of all this. Twice a constant is still a constant. It's something that I'm not sure exactly why, but I enjoy abusing constants in this class. You can abuse them a lot, so enjoy it. U is equal to the square root of x minus 2. So this is 2 times the square root of x minus 2 minus, that'll simplify as the square root of 3. Let's do arctan just for variety. Arctan of square root of x minus 2 over the square root of 3 plus your constant. Yay. Okay, so a little bit of trick there. The one thing that I wanted you to see, and we'll get a chance to practice this later on when we do partial fractions, is this part right here, where we did some long division right there. But like I said, we'll get more opportunity to practice that later on. One last one for this section, going to be problem number 66. Before I move on, actually it's not, is it problem 66? Yes, no, it's problem 60, my bad. Yes, sir, Hans? Okay, good question. So use long division if the degree of the numerator is greater than or equal to the degree of the denominator. That's when you're going to use long division. So you're just going to clean it up as much as possible, and then it's going to reduce to typically either a log term or maybe something like an arctan or something like that. Yes. Thank you. Anything else on 44? All right, so last one here, number 60. dy by dx is equal to square root of y over 1 plus x squared. And they give you a little bonus information here. That is y of 0 equals 4. We'll just kind of keep that around for a while. It's going to be a little bit of work here before us until we actually use that fact. But this is a differential equation. And the way that we can solve this, one trick that we can do is try and get the x's and y's on the same sides together. So dy equals the square root of y over 1 plus x squared dx. So just multiply both sides by dx. In a similar fashion, I can divide both sides by the square root of y. So 1 over the square root of y and 1 over the square root of y. So dy over the square root of y equals dx over 1 plus x squared. Now that's looking a little bit more workable. I'm going to write this with negative exponent. Y to the negative 1/2 dy equals 1 over 1 plus x squared dx. So just moving things around a little bit. But I still don't have a way to solve for y just yet. I've got these differential terms around. Any suggestion as to what can get rid of the differentials here? Yeah, if you integrate both sides, we can get rid of the differentials. Now on the left-hand side, hopefully you're pretty familiar and comfortable with this. Add 1 to the exponent. What's negative 1/2 plus 1? Positive 1/2. Then divide by that same exponent. Now technically there's a plus c here, but since I'm going to get a plus c on the right-hand side, I'm not going to worry about it on the left-hand side. We're going to continue that abuse of constants. On the right-hand side, again, something that hopefully you're pretty familiar with. What's the antiderivative on the right-hand side? I appreciate the effort. Let's make sure that we're still recording. Yeah, we got some voice here. Okay, yeah. Yeah, the tangent inverse on the right-hand side. So, tangent inverse of x. And here we'll throw the constant. This is 2 square roots of y equals tangent inverse of x plus our constant. Looking okay up to here? If you remember, at the start of this, it said y of 0 was 4. What that's saying is if I put in an x equals 0, I'll get back a y equals 4. So let's see what that means for us in this one. I think it's going to allow us to solve for c. So I should get 2 times the square root of 4 equals the tangent inverse of 0 plus c. Take out your calculators unless you know this off the top of your head. Find the inverse tangent of 0. It's up to you if you want to put your calculator in degrees or radians. For the inverse tangent functions, sines, cosines, etc., maybe you're better off in degrees. 0. Yeah, it should be 0. So, inverse tangent of 0 is 0. So you get 2 times 2, which is 4, equals 0 plus c. In other words, c equals 4. Your final answer, if you're looking this up, should look like this. 2 square roots of y equals tangent inverse of x plus 4. You could actually solve for y here. You divide everything by 2. Square root of y equals 1/2 tangent inverse of x plus 2. And then last but not least, and I'm not sure I'm really going to make you solve completely here. I mean, this is fine. You could actually type this into Desmos. Now that's kind of an advantage of Desmos as opposed to your graphing calculator, because with your graphing calculator, you actually have to have y solved for. So you can square both sides and solve for y. That'd be a nice form for y. But if all you're interested in is the graph, and like I said, Desmos and a lot of other computer algebraic systems will let you off the hook right here and graph it there. Looking okay on number 60? Yes, yes? All right. For homework, try 1 through 43, 57, 61, and 63. Now when I assign homework, I always assign just the odds. Now, there's a few reasons I assign just the odds. What do you think some of those reasons are? Yeah, the answers are in the back of the book. I do a lot of the even ones for you. So those are a couple of good reasons. And the last one is I'm a nice guy. I'm saying, hey, just do every other one. So All right. Good luck with your homework. If you have some problems, please get some help.